Hello, everyone, and welcome to the webinar. Today's webinar will be given by Anthony Calderon, our CTO of SolidCAM, on all the new enhancements for iMachining. And this, of course, is being recorded. Before we start, I'd just like to thank everyone who was with us at the conference. We had an excellent turnout for the conference, and it was very informative and very successful in that state. And it was also a pleasure meeting whoever was there. So we'll be doing now a series of webinars of enhancements that we have now in SolidCAM. And as I said, the first one will be an iMachining enhancements given by Anthony Calderon, our Chief Technical Officer. So Anthony, if you want, you can go ahead and start, unmute yourself, and show us your screen, and you can start.
Okay, great. Thanks, Sydney. Can you hear me?
Yes, we can.
Okay, let me hold on. Let me just switch myself to the presenter. Okay, Sydney, can you see my screen? Okay, I'll take that as a yes. Okay, good morning, everybody, or good afternoon for some of you. Thanks for joining. Just to give a heads up, it is 2:30 in the morning here in the US. So I woke up about a half an hour ago. So I am mostly awake, but if I say anything that doesn't make sense, that might be because it's in the middle of the night for me. So yeah, let's get started. As Sydney said, this webinar is on enhancements for SolidCAM, for iMachining in SolidCAM 2018. This is basically the same presentation I gave out at SolidCAM World. So for anybody that got to see it at SolidCAM World, you're going to get to see the same presentation. I have a little bit more time than I had out at SolidCAM World, so I might go into a little bit more detail on some of the items that I kind of sped through there. So yeah, let's get started here. So let me move the webinar panel. Okay, so before we start talking about new features, let's talk about the iMachining algorithm. So one of the more important features nowadays is that the algorithm has become stable and mature. And basically what this means is that we don't get very many toolpath bugs anymore. The amount of bugs that we get today versus even just 2 or 3 years ago is a very small percentage. And this is really important because it's allowed us to focus our development on other areas instead of the core toolpath. Of course, this doesn't mean you're not going to find bugs in the software, because you will always find bugs in the toolpath because it's pretty advanced. But now we get to enjoy the benefits of the toolpath being pretty stable. So what has been our development focus for the past 2 to 3 years? Mostly it's been on ease of use. So this means, as everybody has seen, we've always had iRough, iRest, iFinish, but we've, tried to enhance certain things to be, allow us to do more with 2D iMachining than in the past. So instead of the need to have to use Pocket and Profile in conjunction with 2D iMachining, now you can do more in 2D iMachining. I think everybody's knows that now you can finish the floor with like a contour style strategy, which is from Pocket. So there's a lot of little things we did to try and make iMachining more easy to use. And of course, multi-tool is one of the big things we just added for 2018. The second part of our focus has been a lot of reseller requests. Basically, since the beginning of iMachining, we've always had a lot of requests from resellers. And, generally what we've done in the iMachining development is we've tried to do what was the most important to do first. So obviously things that were, we viewed as a necessity, we worked on those first. So this is a kind of a brief list, and many of these items have been on our list for probably almost 8 years. You know, things we've always wanted to do, but really just didn't have the chance to, you know, work on. So some of these include new material database UI. So we have the new material database UI that matches SolidWorks. You can now use SolidWorks and Inventor materials directly, and we pulled that directly from the CAD system. You can do smaller helical entries. You can now ignore closed pockets in 3D iMachining, which I will review that. You can do a floor fillet in 2D iMachining. We can do stock and open edge offsetting. We have adaptive engagement angle in 3D iMachining, fixture protection in 3D iMachining, rest material from selected operations, which was borrowed from HSM, and we have pre-drilling in 3D iMachining, and the list just goes on and on. So, I mean, this has been pretty exciting for us because, you know, of course, whenever resellers give us requests, we definitely want to add them. So being able to work on these has been very nice. Okay, so at this point, I'm going to do a little demo using iMachining 2D. Also, some of the new things we've done in SolidCAM 2018, I'm kind of gonna, you know, go over even outside of iMachining. So this is kind of my way to kind of show how easy I think it is to demo 2D iMachining now, and to give everybody, you know, sort of a view of how you could demo the software with all the changes we've done. So let me minimize this and open up SolidWorks. Okay, so what do we have here? So I have, you know, I have a part. I have my stock modeled as a separate body. I also have a SolidWorks coordinate system. You know, these are things that you can and cannot do if you like to, you know, depending upon how you like the demo. An important thing to note before we go into creating toolpath is I have a SolidWorks material defined on this part. So I have aluminum 2014 T6 defined on this part. As anybody who's seen 2018 and is using it, you now know we have a new toolbar here, and we have the SolidCAM Manager showing at all times, so you don't see the end user can see this, you know, that SolidCAM is installed, it's ready to go. I'm going to make a new milling, so we didn't have to go to the ribbon or to the menu bar. Okay, so let me pick some of my post processors. I don't have any of the automatic CAM part stuff turned on because I actually want to go through some of the items that I'm doing here. So obviously, many people probably would use the automatic CAM part stuff. So coordinate system. I have my coordinate system that I defined in SolidWorks. So I'm just going to select that. My part lower level. Make sure it is there. My clearance level, I will just fix them. Okay, accept my coordinate system. I'm going to define my stock. I have my box, or I have my stock defined as a 3D solid in my session, so I can just use the 3D model option and target. We'll pick this. Okay, picking the target was an important thing for one of our new options, which is use the SolidWorks material or use Inventor material. So when you touch the target and you define the body, we are now scanning inside of SolidWorks or Inventor for the material associated with it. So if there is a material associated with it, this checkbox will become active. If there is no material defined, the checkbox is not active, and then you have to select your material manually. In this instance, you know, we've automatically created a SolidWorks material called SolidWorks 2014 T6, and in Inventor you get the same IV and slash whatever the material name is. Okay, so I will just go and accept those settings. Okay, first thing I am going to do is I am going to import some tools for this. So I have my tools set up just because it's not so important to define the tools because everybody knows how to do that. So we have my 5 tools defined. Okay, so now we're ready to start doing some toolpath. So I'm going to be using iMachining for everything here, obviously, since it's an iMachining webinar. So first thing I want to do is I want to face the top of my part. So I'm going to use 2D iMachining. Obviously, you could use something like face milling if you like, but this is what I'm going to be using here. We are going to use multi-tool for everything now. So I will define my new geometry. I am going to pick on my top face, and I am going to call this face. Now, in the tool page, you can see there's a new tab when you're a multi-tool. This is for selecting all the tools that you're going to cut. So I am going to use tool number 1, which is a 12mm rougher. I will select it, and then I am going to select my tool number 2, which is a 12mm finisher, just a separate tool. Okay, so now we can see that we have both of our tools defined, and then you can see we have a nice way of just being able to mark what is this tool doing. Of course, every tool is always roughing, but then the next question is what tool is finishing the floor or finishing the wall? So in this instance, we want the second tool to finish the floor. Now, what we will see as we go through the interface, you see we have a flyout in the top left for each tool. As you click and highlight each tool, the UI is changing for that tool settings. So this means that for each tool, you can adjust any of the settings as you like. You don't have to, tool 1 is its own operation. It can have its own machining level, feeds and speeds, and everything. Tool 2 can have its own machining level, feed speeds, etc. So I'm just going to calculate these 2 operations, and let's see what we get here. So we get so just from selecting those 2 tools, marking the second tool as finished floor, we get 1 operation, which is first roughing using iMachining, and then the second operation is using finished floor. And as everybody knows, we default to contour style for finishing the floor now, and you can see that toolpath there. I'm going to go ahead and I'm going to continue programming. I'm not going to use save and copy at the moment because I want to show how easy it is to actually use, set up the operation each time. So we'll go to multi-tool. We are going to define our geometry. So I will pick on the top face again, and now I'm going to pick the outside. So now what we're going to do is we are going to cut the outside shape of the part. And I will name the geometry, and we will call it outside. Okay, so now we want to go and select our tools. Now, in this instance, when I do the outside, I'm going to use 3 tools. So what do I have? I have a 13mm rougher. That's longer than the other 2, than the 13mm I had before. Then I'm going to use a 13mm finisher. And then I have a 10mm finisher for doing the small corner radiuses. So I will pick the first tool. I will pick the second tool. And I will pick the third tool. So the first tool, we're just going to leave as roughing. The second tool, we're going to finish the wall. And also on the last tool, we're going to finish the wall. I should go and make sure my levels are set properly. So my upper level should be the top of my part. The pocket depth should be the bottom. We want to go another, let's say 1 or 2 millimeters off of the bottom. And our floor offset should be 0 because we're cutting the outside of the part. We're cutting the outside of the part, so there really is no floor. So I'm going to set that to 0, and then we'll save and calculate. Okay, and now we see, same as before, we get 3 operations, 1 for each tool. We get the outside roughing. Then we get the, basically this is like iFinish now. So it's finishing the outside. So it's like iFinish, that it cleans out the corner, finishes around the outside. I will simulate the tool path at the end, but we're assuming everybody here is familiar with iMachining. And then the last operation is using rest finishing in just the corners. Okay. We're going to keep on programming. So we're going to make another 2D iMachining. Pull down multi-tool. We will select our geometry. Now this time I want to work on the ledges that are these semi-open pockets here. So I am just going to pick my 3 faces. Let's call these ledges. Of course, as everybody knows, we have Smart Face, so very nice, quick and easy to pick on a face. All the open edges get marked automatically for us. You don't have to do chaining. Okay, we'll go to our tool. Okay, now our the corner radius is on this. We don't have to do rest finishing, so we are just going to do. We're just going to use the tool 3 and tool 4 to rough and finish. So tool number 3, tool number 4, and on the last tool, we're going to tell that last tool you should be finishing the wall and you should be finishing the floor. And let me just make sure I have my operations, or my level set, pocket depth, here, save and calculate. Okay, so first operation is doing the roughing on the 3 ledges. And then we get the pocket style tool path for doing the floor and the iFinish. Now, one thing I'm going to show now is, let me take the stock and I want to hide it. Okay, so we have multi-tool. So we have 2 operations that are linked together. We have now the drag and drop from the CAM manager. So if everything works properly here, when I drag and drop this operation, and hopefully. Okay, so take one operation from the multi-tool, drag it to another face, and you automatically get all the tools defined in the multi-tool on the new faces. So that is super, super powerful. I think that's a really nice tool. Okay, so now what do we have here? We can simulate our part real quick. So solid verification. Okay, we get the facing the top. We get the finishing of the top. I will turn off the tool path. We get the roughing of the outside. We get the finishing on the wall, corner finishing, then we get our ledges, doing the roughing, doing the finishing, doing the roughing for the center pocket, and doing the finishing. So simulation looks good, but of course, one of the main things people are going to ask now is, that's great that you programmed all the tools in one operation, but now I want to reorder all my operations so that way all the roughing takes place first, because I want to save on, either tool change time, or I just want all the roughing to happen at the same time. So now, even though we are defining all of the tools inside of one operation, they are distinct operations in the CAM tree. So we can reorder these as we like. So I'm going to take all the tool 3s and I am just going to reorder them. I can also take the tool 5. Okay, so as you saw, I just reordered a couple of the operations. So all the roughing is done first. We go to the simulation again, and I'll just play through the whole thing. So the first tool does the roughing of the top, finishes the top, and then the roughing tool is now going and doing all the roughing for all the pockets before it goes on to doing the finishing. Okay, so really nice. You can reorder the operations. Of course, I think anybody should have assumed we should do this, but this is something that maybe people think would not be an option in multi-tool since you're defining all the tools in one operation. Now this leads to a new feature we've added to SolidCAM 2018, which solves the following problem. Okay, so the first tool 3 is cutting the outside. So what is this doing? So when we cut the outside, let me show the updated stock. Okay, when we cut the outside, we are actually leaving a little bit of material from the roughing, right? Because we're trying to always leave some material in roughing that we will take off with finishing. Now, since we roughed the outside and we left in a 0.1 or 0.3 millimeters, when we come and do the ledge machining here for these pockets, there is actually extra material on the open edges for the chain, and iMachining doesn't know anything about this. So actually the tool can, one, plunge on material, or the engagement angle is going to be off on the first couple passes. So what I'm going to do is I'm going to kind of make an extreme example of what's going on here. I am going to set the wall offset to 2 millimeters in the first roughing. So let me calculate this. We'll get the new updated stock so that everybody can see what we get. Okay, let me drag this. So, all right, so now we see, so now the roughing on the outside is leaving 2 millimeters of material on the wall. Now, when I simulate the cut for the ledges, what's going to happen? It's plunging down on stock. So what were our options in the past to deal with this situation? It was always left up to the customer or demo guy, whoever's using the software, to manage the situation. So the way to handle that would be to make custom sketches in SolidWorks. So you might have to click on this face, you might have to start a sketch, you might have to start taking some of these edges and you might have to do an offset, put the 2 millimeters on it, and then take those ledges, take the other faces, convert them, then you start trimming everything up. So you do custom sketching all to get the pocket that you need to select in iMachining, or in Pocket, because this option is also in Pocket. You would have to do sketching, align the sketch to the stock, and then make that your geometry. Well, now we've made that a bit easier. And now in Modify Geometry, you can now define open edge offsetting separately from closed edge offsetting. So now what we can do, and I will, hopefully you can see this through the GoToMeeting, you can see we have our chain. We're going to put a 2 millimeter offset, and I will hide the updated stock. So here we see the open edges being offset by 2 millimeters. So now user can just say, hey, there's 2 millimeters extra material. Obviously 2 millimeters is probably excessive because usually it's going to be something like your wall offset amount. But you can say whatever that distance is, throw it in the open edge offset field, and now when we simulate this toolpath, let me zoom in here. Now the tool plunges out in there because now it knows there's extra material, and then the cutting can proceed as normal. I can say for anybody who actually programs in iMachining and tries to use iMachining, for cutting semi-open pockets and things like that, this is a fantastic option. I mean, this is something we've wanted to have for a long time. And the other thing you'll also notice too now is in modified geometry, you can directly define the offsets from the interface if you're applying the same offset to all the chains. So if you need to apply separate offsets for each chain, you can click on the each chain button and then go into the advanced modify, and then you have your the standard modify geometry where each chain you can do something specific to. So once again, ease of use. So everything's now supposed to flow easier, less mouse clicks, anything we can do to make it less work for the customer. Okay, so that goes over that option. We're pretty excited about multi-tool. I think it should really change the way everybody demos the software, and more importantly, the way customers use the software. Much simpler now than using iRough, iRest, iFinish, trying to link the operations. And of course, I didn't mention it while I was doing the operations, but any change that you need to make in multi-tool is very easy now because you can edit any of the operations, you fix it, and then it's applied to all the operations, as opposed to in the previous way, you had to, if you made the iFinish at the end and then you're like, oh, I forgot to do something in iRough, you had to close the operation, go to the first operation, fix it. You might have to go to the second, for the iRest and the iFinish, and you might have to make a change there now, all while kind of jumping in and out of the operation editing dialog, where now everything's in one. Now I have 3 little enhancements. They're really simple, but I wanted to review them because they're so easy to miss in the what's new, yet they're very very critical for cutting with iMachining. So they are minimum helical radius, the adaptive engagement angle in 3D iMachining, and ignoring closed pockets in 3D iMachining. So I'm just gonna run through these real quick and just give an example of what they do. So do the minimum helical radius first. So what do we have here? We have a slot, and we want to try and cut it with iMachining. So what do we typically get when you try cutting a slot with iMachining? You get this error message. Helical entry did not fit into areas. So this is because, as everyone knows in iMachining, we need a certain amount of room to do helical entry, or else the tool, we don't give you a toolpath. And we do this because helical entry is one of the more difficult things on the end mill, and you need good flushing. The harder the material, the more difficult it is. So we define that there should be a big size for the helical entry. The way to work around this is that you need to use either pre-drilling in iMachining, or you'd have to pick a smaller tool, or you'd have to put a hole in your chain, so that way, and actually, like pre-drilling, do some helical entry maybe from pocket or profile. But now what we have in the settings for each cam part, underneath of iMachining, you have the minimum helical ramping radius. So the default is 170%. This is what gives us our best chance of helical entry working on the machine. you can go all the way down now to 110% of the radius of the tool. So if you have a soft material, or you have, let's say you have a tool that has through spindle coolant, and you can flush out the chips. So hey, you can do a smaller helical. Now you can define that. So once you do that, calculate the operation, you can now get a smaller helical entry. Not a very big, not a huge feature, but for customers that are doing aluminum or other soft materials, or they have really good tools for helical entry, now you have a way to tell iMachining that you can do that. Okay, the next one is adaptive engagement angle in 3D iMachining. Okay, so I have a simple toolpath here, just for cutting the semi-open like pocket area here. And what did we do? As everybody knows, we have the engagement angle that you get from the wizard. So this is calculated on the depth of cut. So our depth of cut is 0.7 inches, which is about like 18 or 19 millimeters, and we have an engagement angle of 38 degrees. So one of the requests has been, hey, when you guys do step up and the depth of cut becomes smaller, you should be increasing the engagement angle, because if you changed the depth of cut in the operation, the wizard automatically increases the engagement angle, so you get the same load on the tool. So what do we do now? During the toolpath, and I will jump to Solid Verify, I will do the Show Data window so we can actually see the engagement angle. Okay, so we have our 36 degrees on the first cut. Now, whenever we do step up, I will try and catch the simulation. Now you can see 51 degrees. Every depth of cut in 3D iMachining now is recalculating the engagement angle to keep a constant load on the tool. So you can see the first sledge went up to 51 degrees of engagement angle. And then I'll try and go to the next one. So now we go to 65 degrees. And then we peak out at 66 degrees or 75 degrees on the top ledge. Okay, so now in 3D iMachining, by default, every step up and every depth of cut will get the optimized engagement angle for each cut, exactly as the wizard would calculate it. Now, one of the questions should be, well, what if I don't want that to happen? What if my tool can only cut, let's say, 38 degrees engagement angle, and if I go bigger than that, then I have a problem with, getting the material out of the flutes and so in the modify cutting conditions, you have all of our overrides. If you just say, I want to override the max cutting angle, now we will keep a constant 38 degrees. And once again, I will try it. So the first depth of cut, we have our 36 to 38 degrees, and so 38 degrees, you're going to see 37, 37, 38, just rounding. So now you get a constant engagement angle through the entire toolpath. So we think this makes sense. By default, use the wizard. We are going to adjust the engagement angle for each depth of cut. If the customer or the user or the technician knows, hey, I specifically want to run this engagement angle, if you say, hey, I want to cut this specific engagement angle, we do not do the adaptive EA. Small feature, but very nice. And last one is ignore closed pockets. Okay, back to this simple part we have here. So what am I going to show? I want to cut this part here, but now I have a special tool that cannot do helical entry. So I have a 12 millimeter end mill, and this is now a high performance 7-flute cutter. So what does this mean? Now we are starting to see that tool manufacturers are starting to make specialized tools for iMachining style toolpaths. So what this means is they're meant for, side step over strategies where they know you're not going to take the tool and just bury it in a corner. And what they can do is they can optimize the cutter geometry, so that way it works better for these toolpaths. They can make sharper rake. They can do all these different things. And of course, one of the bigger things is more flutes. The downside to this is if you have one of these high performance end mills, they usually aren't very good at helical entry. You may even get from the tool manufacturer that states helical entry or helical ramping is not allowed at all. So how do you deal with that in iMachining? So I'm going to show how simple this is now. So I have two tools, the 12 millimeter 7-flute end mill, and then I just have a 12 millimeter 4-flute end mill. In 3D iMachining, everything is multi-tool now. So unlike in 2D iMachining where we had iRough, iRust, iFinish, and multi-tool, everything is multi-tool in iMachining. So I now have my first tool and my second tool, and on the first tool, we have the Ignore Closed Pockets checkbox turned on. So what does this mean? This means when this toolpath runs, and I will simulate it, the high performance end mill is going to cut the part without cutting any closed pockets, which should give us 0 helical entries. And then the second tool, since it's 3D iMachining, it automatically works off of the updated stock. We get the helical entry and just the one closed pocket on this example. Now, of course, this is a pretty simple example. You could have made a working area or something, but you could imagine if you're actually cutting like a mold or something more complex, it's much harder to try and limit the tool path to not cut a closed pocket and not have helical entry. And just in case the English term of helical entry is not clear to everybody, helical entry is the ramping, right? So the circular ramping that we do into the closed pocket. And so once again, just to show, tool number 1, Ignore Closed Pockets is turned on, and tool number 2, Ignore Closed Pockets is turned off. Okay, and let's exit. Okay, iMachining 2D with Porcupine cutters or Porcupine Insert Cutters. One of the requests for iMachining in the past couple of years has been, how can we use iMachining with insert cutters? For anybody who was at SolidCAM World, Bakir talked about the cutting they do in Germany and how they all the things that they do. One of the things he did talk about, which if you weren't there you would have missed, is that they do insert cutting with iMachining in Germany, but you have to make sure you have a customer with a big machine with good tooling, and then you have to know sort of what parameters and stuff to run to have insert cutters run good with iMachining. What we're trying to do is we are now trying to develop more of a, let's say, turnkey solution inside of iMachining with insert cutters. So what this means, and let me find my video. This means that we have been working on, hold on, give me a second here and just slow this down. We have been working on making specific Porcupine Insert Cutters that are developed for iMachining. So I just talked, a second ago about the ignore closed pockets because people are, tool manufacturers are developing end mills, which are specific for iMachining. We are doing now the same, we are trying to do the same thing with insert cutters. So if you want to use an insert cutter with iMachining, you should have a different geometry for the inserts and the insert cutter than what you would do for iMachining than if you're doing smaller step overs. So here's just a short little video. You can't hear the sound or anything like that, but this is tool steel. You saw some of the parameters in the beginning, and this is using iMachining style cutting this is a custom tool developed with ISCAR to do the style cutting. You can also see that the cutting is currently dry, which is really impressive. Just to go back to the beginning slides. So 400 meters per minute velocity, 1400 millimeters per minute feed, 40 millimeter depth of cut, and the material is pretty hard, nasty stuff. So now we are starting to do stuff with insert cutters. So if anybody has any interest in insert cutting, I would suggest that you contact Mickey Berman because this is very new stuff. So as I said, we're currently working with ISCAR to have custom tools made up that are made for iMachining. So this is not a solution of where we're saying, hey, you can just take any insert cutter that you find out on the shop floor, throw it at iMachining, and it's going to work. It's kind of the opposite. We're saying now, hey, if you get specific tools that are insert cutters that are meant to work with iMachining, you can get much better performance using an iMachining style toolpath with these insert cutters at a much lower cost than doing traditional insert cutters, because now we actually manage the engagement angle, the inserts are going to last longer, you can cut faster, et cetera, et cetera. Once again, you're going to need a big machine to do this type of stuff. You're not going to take a small machine and just throw an 80 millimeter cutter at the thing in steel and expect it to work. Now I have two features for SolidCAM 2019 that we're working on. Excuse me, let me take a drink. So these are development features that we are working on, and we thought it would be nice to give kind of an insight into what we're trying to do next. So the first thing here is iMachining 2D using stock target fixture and tool holders. So basically, what we are trying to do is we are trying to basically use a merging of iMachining 2D and iMachining 3D, which basically means, hey, you can pick faces that you want to machine, and then we will use all of the 3D model geometry to set up everything for the user. We will look at the updated stock, we will look at the target, we'll make sure we don't gouge anything, we won't hit the fixture, et cetera, et cetera. So let me give a brief kind of demo on what we have working. And so this is now definitely development stuff here. So it isn't perfect. The UI's not perfect, but this is kind of a proof of concept of what we're doing now. So I am going to delete the operations I currently have here. All right, so what do we have? So we have a simple part here. This is kind of this has been our test piece, because in one part we have closed pockets, semi-open pockets, we have the outside, we have the top. So it has a lot of different, geometry conditions that we can, try to manage. So let's make a 2D iMachining operation. I'm not going to use multi-tool because no point in doing it. That's not the point of what I'm trying to show here. So I am going to find geometry. So now, as I mentioned before, the whole goal of this is to be as smooth and as fast as possible for the use of iMachining 2D. So currently, I'm going in the chaining and I'm picking a face. So I'm picking the highest face on my model, and now I want to, I want to be able to rough that face. So I just click accept that. I'm going to go select the tool. You know what? One thing I forgot to do is turn on the CAM experimental for this option. Because if I don't have the CAM experimental, we were not going to see the UI. So hold on. Okay, iMachining 2D, new. Pick our face. We will accept it. I will select my tool. The upper level is there, and the pocket depth is there. Okay, and now what we have is in iMachining 2D, we now have a stock tab. And for anybody who's seen some of the new stuff in Pocket Recognition and also in Pocket, we have cut only rest material. So we are now starting to add generally in SolidCAM to the 2.5D operations, including drilling and such. We are starting to add the stock, the target, and the fixture to make the 2D operations smarter. And now I'm showing what we're trying to do in 2D iMachining. So we have the same thing. We're going to say do the target, and let me calculate. And what do we see here? So I selected just the single face, right? Selected just that face with just that chain. As you know, generally in iMachining, you would have just seen toolpath for just that chain. Now you see toolpath extended all the way to the entire stock. And we show this shaded blue region, which is basically the modified pocket that we are building internally. And as I go over some other options, you're gonna see how that reacts. So we will now save and copy. Yep. Now what I want to do is I want to cut the outside of my part. So I am going to select my chain on the outside of my stock. I am going to select my chain on the outside of my part. I will mark the first chain as open, accept it. The upper level is going to be that face. The pocket depth is going to be that face. And we can just go minus 0.1. Save and calculate. Okay, now this toolpath is cutting the outside of our part. There was nothing really special to do here, but the next toolpath is where you start to see a little bit more of the magic of what we're doing here. I'm going to define a new geometry, and I am going to cut just this face. So this semi-open pocket. Oh, hold on. One thing I forgot to do. Set my upper level and get rid of my delta. Okay. Let's see how well I can show this through the GoToMeeting. So what do we see? We selected this chain, right? So here we have our edges. The roughing toolpath for the outside, actually the tool left a bunch of material in the corner. So we, if you see this blue shaded region, we automatically extended to the stock. If I show the updated stock, just to show better what I'm looking at, right? So on the outside, we would have cut the outside, we would have left material in here. In typical iMachining, we would have, if we would have just selected this face, the tool would have plunged on material, kind of like the same thing I had shown in the multi-tool operation with open edge offset. But in this case, you start to get more complex situations. So now you can just, user doesn't have to know about the stock, doesn't have to set open edge offsetting, doesn't have to worry about it. We take care of all the geometry extension and everything automatically. We also have some options. So you can see here, the geometry was extended all the way out to the farthest point of the stock because we extended the pocket tangentially. You can also choose normal extension. And what this does is this finds the closest point to the stock and extends to just that area. So you can see, once again, if I turn off the updated stock, you can see this blue region updated to that. Okay, we will continue on, save and copy. Now what we want to do is I want to machine this closed pocket here. We hit accept. The pocket depth should be there. I'm going to select a smaller tool. Save and calculate. Turn on the updated stock. Drag this down to here. As everybody I think now knows, the updated stock is now playing in the background. So as you saw, like it was being built and ran in the background. So we want to cut this closed pocket here. Let's say we want to leave a large amount of material on the wall, kind of like the first demo. So the first demo, we left a lot of material on this wall. And now we want to cut this ledge right here. So we say new on our geometry. We pick that face. And what do we get? Hold on, let me just make the wall offset back to 0. Now, and of course there's a lot of stuff going on in the graphics here, so I will try and show what we got. So we picked the face. You can see the face highlighted, the chain highlighted in yellow, but you can see now the blue region, which is the modified chain that we built in the background. So that was now updated and extended to the updated stock, and he gets a toolpath automatically. So in a sense, you can think of what we're doing as kind of automatic sketching in the background. So as I showed in the first demonstration, if you have a situation like this, you would have to start to sketch. You would have to start taking all these edges. You would have to extend them out, get them to the edges, trim, put some radiuses, etc., etc., etc. Now we are doing this automatically for the end user. And more importantly, and this is the cool part of the demo, as you reorder your operations, since it's automatic from SolidCAM, it just happens automatically. You don't have to worry about the updated stock doing anything. So let's say we want to cut instead of cutting the top face first, we want to do the outside first. So what happens? We take that operation. Let's calculate the first one. And then we'll also calculate the second one. And I think my graphics are freezing up here. So first one, we cut the outside. Now, when we cut the top, you can see the toolpath has been modified because we cut the outside first. And the same goes for so we cut the ledge. Let me calculate both of these operations. So in the first for the pocket and the semi-open pocket, we did the pocket first. Sorry, the graphics is, I think, as a GoToMeeting, it doesn't show the toolpath right away. So we have the roughing of the pocket, then we did the semi-open pocket. Well, what happens if we never roughed the semi-open pocket or the closed pocket? We automatically cut the entire pocket when you pick this ledge. So this, as the UI is not perfect yet. As you see, we're still using the chaining geometry. You got to go in, you got to click some check boxes and stuff. But this should have a really, nice workflow to it. You should basically be able to just pick a face and say machine it. We will automatically do the extensions. The user doesn't have to turn on any of the stuff. We're even going to make it that you won't have to go into we won't even have to go into the chaining dialog. We're just going to put just a list, just faces here. While you're in the geometry, pick a couple faces, they get created, and the iMachining operations get created automatically. This, combined with multi-tool, is absolutely going to make iMachining the easiest CAM system on the market, bar none. Because with iMachining 2D, we take care of all the technology. We never plunge on stock. We do all the smart repositioning. The toolpath is optimized because we use engagement angle. The wizard is there to figure out all the feeds and speeds and everything and depth of cuts for the tool you're picking, for the material you're picking. And now you have multi-tool, so you can define multiple tools in one operation, how you want to completely rough and finish that geometry. And then now you have the geometry selection is going to be as simple as just picking on faces. The end user will not have to think at all about chaining. How is the tool going to hit the stock? How do I extend it to the stock? It is just going to be, I want to cut this face. I want these 3 tools, save and calculate, done. We will also automatically find the upper level from the updated stock, define it for him automatically. He won't even have to pick upper levels and lower levels anymore. We will do everything from the target. It basically is going to be, it will be the simplest system to use. And the most important thing is it will be good. Toolpath will be good. So for all of our competition who tries to do things with feature recognition and they say how easy it is to program their parts, but then the feeds and speeds don't work and the technology is not good, this is iMachining. So the technology works perfect. The feeds and speeds are going to work great. The cutting on the machine is going to be way more efficient than you could ever do with Pocket and Profile, and you're all going to get it in iMachining and in SolidCAM as easy as possible. And okay, so that ends. So that ends our sneak peek into iMachining 2D for 2019. Okay, now the last thing. Sneak peek on the new simulation. I think, as everybody knows, there have always been a lot of requests for doing things inside of our simulations, and this is now a task we decided to work on. A little bit of background here. Like 8 weeks before SolidCAM World, Emil had called Mark and I. Mark's our developer in Canada who works on the simulation, and he asked us, hey, now seems like the time we should do the new simulation. It's always been this has always been something we've wanted to work on for the past 3 or 4 years, and let's say haven't had the time to tackle this big project. So Mark and I were like, yeah, we definitely want to do it. It's a good time. Let's do it. Emil put the challenge of, okay, I want to see something in SolidCAM World, and I'd like to present something there. So Mark and I talked. We tried to decide, okay, what could we get done for SolidCAM World, which was 8 weeks away. So what we did, we spent about a week. We went through fly spray tasks, Jira tasks. I mean, there are so many tasks about simulation. People wanting to play backward simulation, people wanting the Solid Verify to have the tool path, with the wireframe of the tool path shown. People wanted to be able to pick on the tool path and drop the tool there. People wanted to be able to click on the tool path and see information about the tool path, like what operation did it belong to, how far away is the tool from the target, all these little things we've had in SolidCAM. And at the same time, I also had a meeting with Bakir and Giselle in Germany, and Giselle had a request to take the simulation, keep it open on a secondary monitor while you were programming in SolidCAM. So he thought that, it would be really nice that while you're programming your part in SolidCAM, you could take the simulation, drop it on a second monitor, and just either be simulating or not simulating while you're programming, but, have something that you could, not have to keep launching the simulation over and over again as you're making changes to toolpath and being able to review old ones. And so that was a really awesome request, actually, and it's one we worked on. So yeah, let me jump in and I'll show you what we got. So this is about 6 weeks of development. Yes, I know SolidCAM World was a few weeks ago, but this is still the same presentation I did then. So this is 6 weeks of development. The simulation's not perfect. It's not the most prettiest thing, but I think everybody will get pretty excited by what they see. And you kind of got to use your imagination just a little bit if you see things that aren't perfect. Okay. I am also using SolidCAM in standalone mode. This is because we wanted to do the integrated simulation into SolidWorks, just like the host CAD, so the rendering is all done in the SolidWorks view. But we decided not to work on that development and to work on another specific thing that I'll show at the end here. So I'm using this in standalone. Now, one thing to note is one of the bigger things we wanted to do was merge all the simulations. So as we know, in SolidCAM, you have 2D, 3D, Solid Verify, Quick Solid Verify, Rest Material. You have all these different simulation modes, and they all kind of act kind of similar, but they all have their different, options and this and that. In the new simulation, our main goal was to merge all of them into one. So here's the new simulation. Okay, so you can see, so this is the floating simulation. You can see stock, you can see the target, you can see the part. You can see we have a scroll bar for all of the toolpath. Some of the things to start noticing here. The simulation is pretty. Everything's floating. You can see the buttons are floating transparently across the graphics. So, the tool, everything is floating over top. The scroll bar at the bottom here, it was supposed to be transparent. We didn't have enough time to get that working. So this gray bar you wouldn't see, you would just be seeing the colors of each toolpath. One thing, I don't know if you can notice it through the GoToMeeting, the zooming, panning, and rotating, we match to SolidWorks. So right now, I am just using the mouse scroll wheel to do the zooming and panning. So wherever you put your mouse, you can see that it zooms just like it does in SolidWorks. This is really cool for me because I'm so used to that style zooming and everything. So you get that automatically. What do we see here? So you see the toolpath. You also see backward simulation. So you can see you can go backwards through the toolpath. As you go through each of the different operations in the list, you get the different colors. You can see it's super, super fast to go forward and backward. You can drag the simulation to any point, start the simulation, hit play. You can see the simulation run. You also get backward simulation. So now you can run the simulation in reverse to see the toolpath running in reverse. You also get, we have like a nice little triad up here in the top. You can see it rotates with your view. So, for anybody who's, obviously familiar with Inventor kind of has a similar looking cube. SolidWorks also has the same kind of cube. When you hit the space bar in SolidWorks, you get like the cube that comes around the entire part, and you pick the face that you want to, orientate the view to, top, left, isometric. So now we have, we've done something nice and pretty to be, the same thing here. Now, one of the things I want to show, obviously, is solid verification. So along with showing the wireframe, you also get solid verification. And one of the really cool features you get, and this was one we worked on, you get reverse solid verification. So for anybody, do this once again, play forward. So solid verify as normal, cutting away the material. And you also can play it in reverse. So this is not some video. This is actually the true solid verify running in reverse. You can also do this in single step. So let's say I single step through. So I single step through a couple points, and then I go, I want to go backwards. Single step backwards, and we reapply the material in a reverse fashion. That I think is really cool. So a couple other things here to note, and I can't show it exactly yet, but so the idea here with the simulation is now everything is shown in the scroll bar. I think people are familiar with this kind of like in machine simulation. You get this toolpath scroll bar. You can take the scroll bar, you can quickly go to whatever toolpath point you want, and then you can start the simulation from that point. You can play backwards from that point. If you have really big, you have a really big toolpath that's like, let's say a 3D finishing, HSM finishing, and you just want to focus in on like one area of the toolpath. Let's say you're checking out the toolpath and you're making changes in the operation and coming back to it. You can jump back into the simulation. You can drag the toolpath to the specific point you want it to be, and then you can start playing and seeing the solid verify just from that point. All the updated stocks are running in the background, and the simulation is fast, really fast. And also you will get, also in the simulation, you will get channel synchronization simulation inside of here. It will not be kinematic simulation, so you're not going to get full machine simulation with all of the components and housings and everything's moving, but you'll be able to see 2 tools, 3 tools cutting simultaneously. You'll get a the scroll bar here that we have for each toolpath. You're going to get a scroll bar for each of the channels. So if you have a 2 channel machine, you'll see the toolpath on channel 1, you'll see the toolpath on channel 2 underneath of it, and the scroll bars will be synchronized, and you'll be able to do the simulation there. So that'll make it easier for people using channel synchronization, especially in Swiss screw and these areas. As you're developing toolpath, you can use this simulation, and then when you're ready to see full machine simulation and have real-time collision detection, then you can jump to machine simulation. One more, another item to note here is on the scroll bar. Currently the scroll bar is broken up by amount of toolpath points. So obviously the first toolpath is facing, so it has the shortest. Then there's the outside cutting, this pocketing toolpath, and then this other toolpath for this pocket here. You'll have options on the scroll bar. There's going to be some options down here where you can break this simulation based on toolpath length, like we see here, based on cycle time, or based on or equally divide it. So that way, if it was equal, you would see each one of these, with the same length, and when you scroll through, you'd get the same, the same size for each one. Or if you did toolpath length, or I'm sorry, cycle time, let's say this operation might actually be the shortest amount of toolpath, but it takes the longest cycle time because the tool's really slow. It would be longer than the other ones. So we're going to try and make a whole lot of nice, cool features in this simulation that'll make it very user-friendly. And yeah, that ends my presentation. Sydney, should we ask for questions or anything, or?
Okay. First of all, thank you very much, Anthony. Even though it was an extended webinar, but it was definitely interesting. And even though I've seen this before, or it looks fantastic every single time I look at it.
Awesome.
It has been an extended webinar. There's only one question if you want to go through it, or
Yeah,
that's okay with you?
Yeah.
All right. Do you see the question?
When will the functionality be available in iMachining for NX?
He's talking about, I think, the functionality of multi-tool. That's when he wrote this.
Oh, okay. So, multi-tool, unfortunately, will not be in iMachining for NX because we do not have the ability to do that in iMachining for NX. So since we use the dialogues and the tools and everything from NX, there is no way to do multi-tool with the little window and everything that we did. However, all of the toolpath functionality should be making it into NX, and specifically this is the stuff I'm talking about for the what's new for iMachining 2D using stock target fixture and tool holder. That will be available when that's in SolidCAM 2019. That will also be available in NX. So also in NX, when you use 2D iMachining, it'll use the stock and the target and the tool holder from NX to generate that. And please show again the drag and drop. Yeah, absolutely. Yeah, it's from the demo, it's really hard to see the drag and drop. So let me open up SolidWorks again real quick. And and I guess some of the stuff I went through on the presentation, I was familiar with what was presented at SolidCAM World. So hold on.
By the way, in one of the future webinars we'll be going more in depth also into drag and drop. But continue.
Yeah, yeah. So I mean, so Sydney will be showing the drag and drop templates and everything, and there's so much functionality with drag and drop. It's awesome. It was awesome. So what did I do here? So once again, which toolpath was I working on? The ledges. So now, if you take an operation and you hold down Control and you drag with your mouse wheel, you can drag the operation to a face. And at the end of dragging, we automatically do the smart face option. We find the face, and we create the operations directly using that geometry. Definitely you need to watch Sid's webinar on this because he goes over all the ways it works, because you can drag and drop from over here. He talks about that it creates so many cool things. I don't want to give away the cool things that Sid does. But yeah, so it's as simple as just holding Control, dragging it to a face, and you get your toolpath.
Okay, Anthony, thanks a lot. Again, I think you deserve a good sleep now. Take care, and we'll hope you all joining us for our next webinar. And this, again, has been recorded and will be available later on our website together with the parts that were used. Okay, so everyone, take care. Have a great weekend.
Thank you, everybody. Bye now.